Okay, in this tool I'm going to, or in this lecture I'm going to show you how we can create some planetary system. And we're going to do this in two parts. So first of all, what we're going to do is we're going to see how gravity can distort or deform actually the geometry we see on a grid. So the first thing that we're going to start by creating is we're going to create a grid shape. And so just make sure that this grid is big enough. I'm gonna, oh no, that's translation. Sorry. So it's over here. The size is going to be 30, and the rows I'm going to use are something more. Let's have 60 rows over there. And again, I haven't put it yet to the ground, so something like this. And instead of using just a standard grid, what we're going to do is we're going to change it into rows and columns. And like this, we're going to have like multiple primitives. So just a set of lines actually. And that makes it easy for us to just see through the whole thing. So the next thing that we're going to do is we're going to create one single point. We're going to create something which creates the gravity for us. So that one single point is going to be created by using an add node. And we just use one number of points, make sure that it is activated, and we just see one single point over here. Okay, so we need to make sure that the grid is going to be influenced by what we have over here. So how are we going to do this? For this we're going to use a FOPSOP. So this is going to be a lecture about how to use FOPSOPs. And we're going to get both of these elements in. So we're going to connect the grid to the first input, and the first input is always the input that's being used to actually recreate the geometry. Over here you can add, like in the multiple inputs, you can add like other shapes on which you can retrieve some data that you want to use over here on the inside. And that's exactly what we're going to do. We're going to use this point to do something what we can do over here. So the first thing is as follows. The first thing that we need to do is we need to make sure that we are going to get that information of that second point. Now over here in this global node, we saw that last time, we see like all the information, all the attributes coming in from the first input, which is this global node. So we see the point position, the point W coordinate, all those other things. But we need also to have the point position of that second point. Now we can't get that over here. If you look at the globals, you see that you don't have like any means or so to get like a second or third input port selection. So how to do that? Well, you find it right over here in geometry, and in the geometry we can import an attribute. Again, this clearly shows you that attributes are really the key of everything. So if we want to get like the position of that one point, the attribute should be, and you can think of it, uppercase P. So what we're getting right now is the following. We're getting like this point, and we see this point number, or this P, is just coming directly from the first input. So if I connect this one over here, we see nothing is going on, because right now it's set to up input index 0, which is the first input, which is normal. So the moment we change this to 1 over here, now you see everything is being collapsed to the single point, because it's getting now the information from the second input port. But wait, you're gonna see it's still not complete, because what you would expect if I'm going to transform this point right over here is that when I transform the whole thing, that all those points will follow. Now when you do that, you see actually there's only one point which is being transformed over here, and we can see which point that is, and that is point 0. And the reason is very simple. There just is one point. There's nothing more. There's 1 point. So for the rest, it can't find any attribute data anymore. So it's taking the default value, which is going to be 0. And so all the rest of the points are just being condensed over here. So how can we solve this? Well, we need to force for the evaluation for each point over here that it's always going to take like the first point number. We just have 1 point, so we have to set over here the point number. And for that we're going to create a constant, which is this fixed value, and we're going to make this into an integer, and we're going to connect this way. Now the moment you do that, for each point it's going to use point number 0, and so when I do this, you're going to see all those points are going to jump over there. Okay, so this is the very first step. So that's about importing attributes. Now what we want to do is we want to do the following. We're going to measure the length between the point position of that 1 point that we're measuring and the point position of the points of the grid. And we're going to use that length to control the y position. So I'm going to make like a small demonstration on how that would look like, and then you can try to solve this yourself. So I'm going to pause. So this is the effect that you are supposed to see. You can see it right over here. The moment you start moving your point, we see how everything is reacting to that. So as you can see, I'm measuring actually the distance from this point that we're moving, and we're measuring the distance for each point. And what I'm doing is I'm using that distance to have the points being moved into the y direction. So this is what we're getting. Okay, so how did I do this? Solution is as follows. There are many possible ways, but one of the ways that you can do this is the following. So first of all, you need to measure the distance. Measuring the distance is also the same as saying, okay, I'm going to subtract this position minus this position, and up, I'm going to measure the length of that vector. Up. So what we're doing over here with these two nodes is exactly the same as the distance. So if I connect it over here, you won't see any difference at all. So these are two methods. Right over here, setting the vector component is also one of the methods. Another method would be, which is not that short, but it's also valid, is using a float to a vector, and we're also going to use a vector to a float. So what we're going to do is over here, changing vector to float, we're going to still write the x and the z values, reconnect this over here, and then connect, for example, the length over here. Also, this is entirely valid. So what you see over here is actually exactly the same what we're doing inside of the set vector. Now a third one, which was kind of interesting, is the following. You can use also displays along normal. So you can take the point positions, you can take over here the displacement amount, and then here we can see the displays, let's see, displaced position. So if we connect this over here, we see the displaced position. But wait, I see something which goes like really strange over here. Now the reason for that is that we don't have like a proper normal. So if I'm going to set right over here with a constant, a normal value, and I'm going to make this into a vector and set the normal pointing upwards, connecting that one over here, you also get that same result. So all of these methods are actually valid. So I'm going to bring this back to the first thing that I had, set the vector component, because I think this one is the cleanest. We just have like exactly one node and just one connection to make, and so this is most likely also the fastest method. So that's about this part. Now the thing is, when we want to have a gravity field, we want to have something different. We don't want to have the fact that that everything is increasing according to distance, but with gravity you want to have the gravity being increased the closer it gets to the object, and also you want to have like this ramping up, so a quadratic decay actually of the gravity field. So try to solve that. It looks a little bit like this curve kind of shape, so let me draw this. So if you would have like this point over here, you would expect to get something going like this in a very steep peak. So you see this like slowly going up. This is already not touching the grid. It's just barely touching the grid, or not touching the grid at all. Sorry, it's not touching the grid, but moving up and goes faster, faster, faster until it like really goes up. So that's what we need to have. Okay, what is it? This. All right. So I'm going to pause the video and going to show the solution. Okay, so this should be more or less the effect you should get. Now keep in mind, if you made the grid a little bit bigger or smaller, it kind of looks bigger or smaller, this kind of effect. So it's really working in world space. So if I would make this grid, let's say the size of 10, you're gonna see like a totally different kind of result. You see? Now also, which is important to notice, is that the moment you would have like, let's say 61 rows, see like this middle point is going to disappear. And you can get a clue out of this because it's like giving you the singularity of a black hole. In fact, it would be endless, and you can get an endless result if you divide something with something. So that's kind of a clue. Now you will see the moment I start moving this point, just when there is like this small difference, already you see the effect of it. So here we see like this effect of this black hole-ish kind of thing. Okay. So how did I do this? Well, it's very simple, just one thing, an invert node. Now, we're not going to use the invert node. The invert node is actually something that you also use, not with a float, but with a matrix. It's especially used over here if you want to invert like a rotation matrix or transformation or things like that. This is how you do that. Now, what we can do as well is we can set our value, and we're gonna do this right now with a constant. So we're gonna start over here with a constant value of 1. So that would be as if you have like a planet or an object which has like the mass 1. So that's the first thing, and what is important is it's a little bit the same like using a complement. So if you want to know what a complement is, look it up. You can find it over here and see what it does. Now divide is something similar to that. So if you divide 1 by a value, you get something like this. So what's going on? Well, if you think of it, it's very simple. So think just of a set of values. Think of, let's say, 4, 2, 1, a half, 2.20, something like that, or 0.20, things like that. And see how actually those things are really influencing how much, what kind of value you would get out of that if you would start feeding those values inside the second input of the divide. Now, of course, we want to show it like in a movie or something. So we're not going to make it push upwards, we're going to make it push downwards so that it feels like really a black hole, like a gravity pull. So we're just going to add a negate, so it's just making the value negative, and here we see our black hole. Now we don't see like these very nice curvatures over here, so we're going to make it a little bit more beautiful. So I'm going to set this to, let's say, a value of 20, but also, and now you see like these very harsh lines, what I'm going to do is I'm going to resample the whole thing. And so when you resample, yep, that's not a good idea. 0323 would be too much. 6666, something like this. I think this looks quite nice. So now you can switch over these points and you see how you get like this really nice curvature of the bending of the whole surface. So this feels like this really heavy gravity well. Now there's a small thing that I want you to do as well. Right now you've created actually a singularity. So it's when you get like the close to the point, it is actually going to be of endless, it's gonna have like endless gravity, because the point has like a mass of 1, but it's infinitely small. So we need to change that some way. We need to make sure that we're gonna distribute our gravity in a way so that we have like some kind of mass. Now we want to control this right over here. So right now we don't have like any controls over at all. So how can we control those things? Well, instead of using a constant, you can also use a parameter. And so a parameter, you can see over here, it has like this knob as a symbol. The difference between a parameter and a constant is that the moment you start fiddling over here with these values, you see it is updating, but it's kind of sluggish. Yeah, most probably you won't see the sluggishness or the difference over here at all. But if you try it at your machine, you're gonna see it's actually not that fast. It's very slow. And the reason for that is that if you're adjusting a constant value, then it is constantly, completely re-evaluating and recompiling the whole network. Now if you use a parameter, which we're going to change to a float, and we're going to change the parameter name, let's say to mass, then we can control that better. So we're going to have like, oops, can't connect it over there, and just pressed E so I'm able to move it wherever I want. And the mass I'm going to give it like by default a very small mass, but I'm going to allow it to go very high. So this is the default value, so not that heavy, and the lightest value is going to be something like this. So what do we have? We can just increase the mass. As you can see, it's going to be like this very heavy big object. Now it's at its singularity, again, it won't make any difference at all, because at the singularity the weight or the gravity is infinite anyways, but it's like this whole change we see over here. So what I want to see is the following result. So try to solve and get the following result what I'm showing you over here. So what I have over here is we have like this gravity well, but now we can also control the density a little bit. And we see over here, if we move the density, you can move it up to a higher value, and then you have like a very low density on the surface. So that would be as if you have like this very big sphere, something like this. Now of course it doesn't make any sense if you see it over here as a parameter. So right now we see that the lower the density is, actually the more dense it is, and the denser we make it, the less dense it is. So we need to change this. We need to make sure that we're going to have like this nice gravity well. Now let's first have a look on what I did. So this was what we had as an original shape. So we imported like the point position, and we directly connected it and measured the distance towards this point. Now what I'm doing over here with this density, I'm just adding a value in the y direction, and I'm adding this value to the point so that it's actually floating a little bit above the surface. And so the higher it gets, the density is going to, or the distance being measured, is going to be not linear anymore, but is going to fall off using this direction you see over here. So you have like this point from here going more and more and more, like with this race almost. So that's why you get like this rounded kind of shape. So we're gonna try and keep that, but what I really want to have in the end is that if I go over here, and I'm gonna give you a small hint, you can't go below something like this. If you go over here, you will have a density of the lowest density possible. So it's almost as if the weight of the object is completely spread over the whole universe. So you can see it a little bit as follows. You can have like a kilo of air, and you can have like a kilo of lead. A kilo of lead is of course much more dense, it's much more compact. A kilo of air is going to be much bigger in volume. So here we're talking about an endlessly big volume, and right over here, if we go to something like this, we're talking about an endlessly small volume, so extremely dense. So these are the values you will have to put in. So try to solve this, and again I'm going to show you what the result should look like. So the effect of your density should be as follows. If you move it down, you get like less and less density to no density at all, and if you move it up, you get like to infinite density. So very deep black hole, as we can see right over here. So this is something you can use. Okay, so how did we do this? Well, you can pause the video here if you still want to solve it, but how did I do this? Well, it's actually very simple. I take over here, I make like an inversion. So again, the invert, remember, it's like being that 1 is being divided by the density value we see over here. So the lower it gets, the more infinitely high that value is going to get. So if we have like this infinitely high value, then we're gonna get right over here, you see this vector being moved up. This point is going to be moved up to infinitely high. And so if you're going to measure the distance right over here, we're going to have like an extremely big distance. And since the distance is so high, we don't see like the effect of it almost anymore, because it's equally spread to all sizes. So over the whole field we have like a little bit of this gravity, but it's not like really centered somewhere. So the mass is still there, but the gravity doesn't show anymore, because it's like infinitely big. Okay, so what else do we have right over here? We also have the, oops, I have been pushing over here my volume. I hope it doesn't affect the playback. So what we have also over here is, instead of doing infinite, is we also have like a subtraction of the value we have right over here. Because what's going to happen is the following. The moment we slide with our, the moment we go with our slider to 1, we get like 1 divided by 1, and this will result just very simply in a value of 1. Now we don't want to have that. We do want to have a value of 0 if we want to have like an infinitely small object right over here. So while we're having over here a value of 1, if we slide our slider to 1, I'm also at the same time subtracting the value that we have over here directly. So if you slide to 0, the 0 is going to be subtracted. If you slide to 1, 1 is going to be subtracted. If you slide to 0, this value is going to be infinitely high. If you slide to 1, this value is going to be 1. So this is what you're going to get if you implement it this way. Now we're not going to make it look as it is right now. We're also going to add something different. We're going to make sure that we can add some nice colors to it as well. So right over here I'm going to show you another kind of parameter that you can use. And right now we've seen how we can use like a constant, we have seen how we can use a parameter, and it's always good to give them like the right color coding. So if you have parameters, just use color C and give them like this yellowish color. This is also what Houdini is using by default. So if you zoom out, you see immediately where those parameters are. Now the other thing that you can use is, again, let's go to utility, and this is this one, the ramp parameter. Now what do we get over here with the ramp parameter? With the ramp parameter you can get over here a float value which is going to select something on the ramp between 0 and 1. So what I'm going to do over here is we're going to use this parameter as a color, and we're going to connect it over here to the color attribute. So let's just have a look on how this is going to affect what we're going to see. Show UI controls by default. I'm going to switch this off because that's a little bit too busy. So the UI controls that they're talking about are these ones. So we don't want to have them by default. So okay, what do we see? We see over here our color, and we see everything is just being like white. Let's see if we can change anything over here. I think we might need to change what we have over here, because we're talking about these distances, although I think it's rather strange that we don't see anything at all right now. So let's do a multiply constant, and what I'm going to multiply over here is the distance. So the smaller, or this distance, we're going to make these values a little bit smaller, and so right now indeed we start to see like some effect of that. Now to make this even better, let's change this over here, go to my background, we're going to make it a dark background, and so now you see what's going on. And again we can change the colors over here. I'm going to connect it, actually not with that, but I'm going to connect it with what we see over here. So we're going to have like this negative value. So here we see already the effect of the mass. Okay, so now we can go up and we can start really using some nifty nice colors. So you can use whatever you like, but I'm going to use over here some yellow, some reds, and some purple kind of colors. Purple, dark purple kind of colors. Something like this. Can be a little bit more visible, I think. Let's put it this way. Okay, so now we see the effect, and so if we start to increase the density, we're gonna see the density actually being shown over here in our gravity well. And so if we move our point, we can also move it around using an animation that's even nicer. So use like a sinus of the time, and we're going to multiply this by 10, and I'm also going to do this with the cosine. Over here. So once you would see this, it's perhaps too much do it by 5 because it's now just touching the edge. So now you clearly see how this gravity is affecting this whole thing. Okay, so that's the very first part. Now in the second part we're gonna see how we can solve this, how we can do this using much more of these things. We want to have like much more points, because what we do right now is we just have like 1 point and we set our values manually. So for the next step we're gonna set values using attributes so that we can have like points with different kind of masses, and also we're gonna make sure that we can have multiple points being used right in here. So that's the end of the first section we have right now.